Okay, students, in this lesson, we're going to talk about the various forms of equations and then how to solve for equations and literal equations. So let's go ahead and start with the three different forms that we know. They are general form, which is in the form of y equals ax plus b, or you're probably more familiar with y equals mx plus b, which is also known as the slope-intercept form. Then there's the standard form, which is ax plus by equals c. And the last one is the factor form, y equals a times the quantity x minus c. There are advantages and disadvantages to each form in terms of determining y-intercept, x-intercept, for example. But these are the three different forms that you should be aware of. In this lesson, I'm going to show you how to convert from standard form to the general form, and then also the opposite, so from general form to standard form. Okay, so let's go and get started with the standard form. We know that it is ax plus by is equal to c. Since we want to solve for general form, we want to end up with y on one side of the equation and everything else on the other side of the equation. Okay, so the first thing we're going to do is move this ax over to this side of the equation. And to do that, we're going to need to subtract ax from both sides. So this then becomes by is equal to negative ax plus c. So you're going to notice that throughout this lesson, in all future lessons, I am not going to write out every step that takes place. So it's important that you recognize what happened here. Okay, so if you think about this side of the equation to the left, okay, we started out with an ax, now it's gone, so we subtracted that. When we subtract this side of the equation, we have to do the same thing to this side of the equation. So there was no ax here, we subtracted ax on the left side, so now we need to have a negative ax on the right side of the equation. Once you have that, then we need to divide the entire equation by b to get rid of b on the left side. So then what we get is y is equal to negative a x over b plus c over b. When you're multiplying or dividing on one side of the equation, you need to make sure that you're multiplying or dividing every single term. Okay, so we divided this term by b, so b divided by b gives us 1y. This is why b disappears, because it's implied that there's only one y. So if we divide this term by b, then we need to divide this term by b and this term by b. This is why we have a negative ax over b, because we're dividing that term by b, and this is c over b, because we're dividing this term by b. Okay, so let's try a specific example. Let's suppose we have the equation 2x plus 3y is equal to 5. Okay, so the first thing to do is we need to subtract 2x from both sides, because we want y to be by itself. And to move this over to this side, we have to subtract it because of this positive sign. So then what we get is 3y is equal to negative 2x plus 5. Now we want y to be alone, so we need to divide this term by 3. And if we divide this term by 3, we have to divide this term by 3 and this term by 3. So then the result is y is equal to negative 2x over 3 plus 5 over 3. And this is your answer, going from standard form to general form. Okay, standard to general. So now we're going to do the opposite. We're going to go from general to standard. So our general form is y is equal to ax plus b. And we want to move to standard form, which is ax plus by is equal to c. Okay. What this means is we already have y on the left side of the equation, which is what we want. Now we got to move this x term to the left side of the equation so that it looks like this. In order to move this from the right side of the equation to the left side of the equation, we have to subtract ax to remove this because we're adding this term. So we need to subtract it to move it over to the other side. So what we get is negative ax plus y is equal to b. And that's our answer in standard form. Now, you may be wondering why you have this b here, but then you've got this b here. Okay? These b's are not exactly the same. So this b is in reference to the y term. So that's what we moved over here. This b is actually a constant. So this b is the same as this c, which is your constant. Okay, so don't let the a, b's, and c's throw you off, or at least the b's here in this case. So let's follow this up with a specific example. Okay, let's suppose we have an equation that looks like this. Y is equal to negative 3x plus 10. And we want to convert that into standard form. Okay, so the first thing to do is we already have y on this side of the equation, right? Because it matches this. We want x on the same side. We've got to therefore move this negative 3x over to this side. And in order to move it, we have to add 3x, okay, because this is a negative term. So when we add 3x, we get 3x plus y is equal to 10. Okay? And that is in standard form. We're going to try another example where we have fractions, and the reason I'm bringing this up is because there's one additional step that needs to be done towards the end. So let's say, for example, we have y is equal to 1/2 x, let's make that negative, minus 4/2. Actually, let's make that 5/2. Okay, so there are a couple of ways that you can tackle this problem. I believe that the cleanest way is to multiply this entire equation by 2. And the reason we want to do that is because we want to get rid of the fractions. Okay, manipulating fractions adds a level of complexity, and we want, in math, we always want to keep things as simple as possible. Okay, so the first thing to do, as I said, is to multiply this whole thing by 2. We're going to multiply this by 2. Okay, this means that we're going to need to distribute 2 times y, 2 times this negative 1/2 x and 2 times this negative 5/2. Okay, so if we distribute that through, we get 2y is equal to negative x minus 5. Okay, then the last step is to move this negative x term over to this side because we wanted it to be in standard form. That looks like this format. Okay, so to move this negative x to this side, we have to add x to both sides. When we do that, we get x plus 2y is equal to negative 5. And that is in standard form. So hopefully that was pretty straightforward. We just covered how to convert standard form to general form and then general form to standard form. Now I'm going to share with you equations that have one solution, infinite solutions, or no solutions. So here are the three different kinds: one solution, infinite solutions, and no solutions. So I'm going to give you an example of each one so you have an understanding of what each one of those mean. So if we take a look at the first example, one solution, we can go ahead and solve for y, and we get 2y is equal to 16 because we add 4 to both sides to get rid of this negative 4y. And then to remove the 2, or to move the 2 to the other side of the equation, we're going to need to divide both sides by 2, and we get y is equal to 8. Okay, so in this example, this is a one solution problem. Now if we move over to the next one under infinite solutions, what you'll see is when we solve for y, here's what happens. We're going to combine the y's on the left side of the equation. Okay, so we're going to take 2y and we're going to subtract y, and we're going to get y minus 6 is equal to, and now I'm going to combine these, the negative 2 and the negative 4, and we're going to get negative 6 plus y. Okay, now you'll notice that y's, there's a y on the left side of the equation and a y on the right side of the equation. When you have that, you can cancel those out. So what you have left is negative 6 equal to negative 6. When you have this scenario, this means that you have an infinite number of solutions, because whatever y you put into the equation will always make the equation valid. Okay, now moving on to the third, with no solutions. So if we do the same thing and solve for y, here's what we get. 3y plus 4 is equal to, and now I'm going to combine 2y and the y on the right side of the equation, and we get 3y plus 6. We have 3 y's on both sides of the equation, and so those cancel out, and we're left with 4 equals 6, which is not true. When you have this scenario, this means that you have no solutions. Okay, so here's the difference. In the infinite solutions, the left side and the right side are exactly equal, and so therefore the number of solutions is infinite. In the third example, we have 4 not equal to 6, so this is not balanced. And when this happens, and when the variables are canceled out, you have no solutions there. Okay, so let's move on to the last topic, which is literal equations. So to define literal equations, these are equations in which the variables represent specific measures. So an example of this is the formula for the degrees in Fahrenheit and degrees in Celsius. Okay, so for example, you've got a formula for degrees in Celsius, which is equal to 5/9 the degrees in Fahrenheit minus 32. So this is a literal equation because there are variables, in this case C for centigrade and F as in Fahrenheit, that represent those specific measures. So when you're posed with this type of equation, sometimes you'll be asked to solve for a different specific measure. So in this case, the equation is in centigrade for C, and now we're going to convert this equation into Fahrenheit. So to do that, there are two ways to do this. One way is to multiply the entire equation by the reciprocal of 5/9. And the reason we want to do that is because we want to eliminate that fraction. Okay, so what we're going to do is multiply this entire equation by 9/5. And what we get is 9/5 C is equal to, now the 5/9 cancel out because of the reciprocal, and what we have left is F minus 32. Since we want F to be alone on one side of the equation, we're going to need to add 32 to both sides. And what we get is F is equal to 9/5 C plus 32. So let's go over another example. Let's take the equation in factor form. Y is equal to A times BX plus C. And we want to solve for X. So we want X on one side of the equation and everything else on the other side. So the first thing to do is to move this A over to the other side of the equation. And to do that, we have to divide both sides by A. And what we get is Y divided by A is equal to BX plus C. Then the next thing we need to do is to move the C over to the other side of the equation. And we do that by subtracting C from both sides. So then what we get is Y over A minus C is equal to BX. And then the last step is to move this B over to the other side of the equation. And to do that, we have to divide both sides by B. So then what we get is Y over AB minus C over B equals X. And that is our answer. So whenever you're given a literal equation, regardless of which variable you're going to solve, the key is to follow the algebraic rule and move everything over to one side of the equation and leave the variable that you're solving on the other. Hopefully this made sense. If any of this was confusing, please go back to the beginning of the video and review the video again. Thank you.